Hey guys, welcome to linear programming. So this is an interesting topic that is derived from graphs of inequalities, and of course this is full of vizungu. So the first thing we're going to learn is how to translate grammar into mathematics symbols, because this is what linear programming is all about. It has three parts, which are: first, developing inequalities from word statement. So you'll be given word statement. Your job is going to be to change this word statement into inequalities. Then the second is graphing from inequalities. So once you have changed these word statements into inequalities, you have to create graphs from these inequalities, just like we learned in graphs of inequalities. Then finally, the last step is to solve what I call a problem function. So a problem function is just they'll give you a problem, then and maybe you need to come up with a function or an equation that describes that problem, and then you need to solve that problem using your graph. So these are basically the three parts. So graphing from inequalities, you already have this skill. Then developing inequalities from word statement, this is what we're going to learn. It's just learning chizungu. They will give you some statement. Your job is going to convert that statement into mathematics. So let's get started. So whenever I find more than, it means greater than. As simple as that. If you find less than, it means less than. So where there's more than, it's this. Less than is this. Simple, huh? Then there's not exceed. Not exceed means less or equal to. If I say that the number of tomatoes should not exceed 20, this is what I mean, should not exceed 20. So it means the number of tomatoes should be less or equal to 20. At least. So at least means greater or equal to. If you remember when we were doing sets, if I say find the number of students who take at least one subject, we're looking for numbers who take 1, 2, 3 subjects. So we're looking for those who take one subject, then those who take 2 subjects, then those who take 3 subjects. We start with one subject, then we keep on building up, because at least means less than. And there was that example that I gave for those who can remember about the way newscasters present their news. For example, if there is some incident that has caused some fatalities, they say at least 20 people have died, which implies that 20 people or more than 20 people have died. The ones that were that at that particular point everyone's sure of is 20, but maybe there are more. So that's why they use the word at least, those who have been confirmed to be dead. Then those who haven't been discovered, we don't know. So we can't just say 20 people have died. What if there are others? So that's what it means, at least. It means greater or equal to 20 in this case. Not less than. So not less than basically means greater or equal to. If I say the number of tomatoes should not be less than 10, I mean the number of tomatoes should be greater or equal to 10. At most means less or equal to. If I say the number of tomatoes should be at most 20, so I mean the number of tomatoes should be less or equal to 20, or the greatest number of tomatoes we can have is 20. It shouldn't be above 20, and it shouldn't be, it shouldn't be above 20, but it should be 20 or less than 20. That's what at most means. It's the opposite of at least. Not more than. Not more than means less or equal to. If I say the number of tomatoes should not be more than 20, I mean the number of tomatoes should be less or should be less or equal to 20. With that, let's take a look at the second part. That is how to deal with a problem function. So the first part we've talked about grammar. The second is, of course, graphing from inequalities. So that one we're going to skip, because we learned from graphs of inequalities how to graph from inequalities. So let's say the English they have given you, you have converted to these inequalities. 1, 2, 3, 4. So you have converted to these inequalities. So the next job is, of course, to graph using these inequalities. So let's say you graph, you end up with these graphs. Remember, less than means dotted line, less or equal to means solid line. So for example, y less than 1, we're talking about this line here, which passes through 1, because it's a horizontal line, so it's going to be y equals 1. And if you try to put inequalities, you look at the region R, it's greater. So the region R is greater, is on the greater part, so this is supposed to be y greater than 1. So I'm sure there was a mistake here. Yeah, so it's supposed to be y greater than 1. If you follow these other ones, you're going to get this. So here it's supposed to be greater than 1. But anyway, that's not the main point we're discussing here. So let's say you have this and you plot your graph, you have this. So what's next? So you look for the problem function can be, what is the maximum value of x plus 4y? So they are going to ask you, like, using the graph you have drawn, find the maximum value of x plus 4y. So using the graph, find the maximum value of x plus 4y. So to find the maximum value of x plus 4y, here's what to do. So you identify the points which are called crucial points, pertinent points. You can call them whatever you want, but basically they are points on the corners of the graph, or there are many points where you can get different values on the region R. So if you look at your region R, there is this point here, there's this point here, there's this point here, there's this point here. So you can pick these points to find out. They are going to give you different values, and they're the ones we use to solve a problem function. That is the points on the corners. So picking this first point here, if you look at this red part here, this is not the corner, but I've picked this point as a corner point. Why? So there's that thing of inclusion and exclusion when we're talking about inequalities. I said solid lines shows inclusion and dotted lines shows exclusion. So when you're picking points, don't pick a point that is on a dotted line. Pick a point that is on a solid line. Okay? So if we pick this point at the corner, it's on the solid and the dotted line. So we want to avoid being on the dotted line, because dotted line shows the part of the inequality that we should not consider when you're analyzing this region R. So what we do is we shift it a bit to here. So this point here is on the solid line, but it is a bit away from the dotted line. If you want, you can even choose something just in between the two here. So it's also going to give you something. So this is one of the crucial points. So its coordinates, you have to pick its coordinates. Its coordinates, if here it's 1, then maybe here it's 1.5, just approximating, and here it's 1. So the coordinates are 1.5 and 1. So you go to the next point, which is that one. Again, if you look at this point here, I haven't chosen the point here because it is where the dotted line passes. So I've chosen the point just a bit close to the corner point, but on the solid line, because I want to keep away from the dotted line. So the coordinates of this one can be 4, 4, and you go to the next point, this. So why this? The next point is supposed to be this one here, but again, because of this dotted line, so I won't pick it. I'll just pick a point that is on the solid line but a bit close to the dotted line. Want to avoid the dotted line, so this can be the closest. Of course, depending on how your handwriting is and how your eyes is, you can choose something that is here. It doesn't matter. Don't expect to get the same answers with your friend, but they should be close. So this can be 6.5, 3.5. So the next point is here. So here again, I'll avoid this dotted line. I'll pick something from here, because here it's a solid line and here it's a dotted. So instead of picking here, which is between solid and dotted, I'll just shift it a bit. And when I do that, I'm going to have this point, which is maybe on the nearly the same as this one, 6.5 comma. I mean on the x 6.5 and on the y it's 1. So I've got these points, 4 points, 1, 2, 3, 4. So once we have these points, we're going to test them on in our problem function, that one which they had given us of the maximum value. So we're going to do this. So these are the coordinates: 6.5, 1, 6.5, 3.5. So 6.5 comma 1, it's this one here. Then the second one 6.5 comma 3.5, 6.5 comma 3.5, which is this one. Then we have 4 comma 4 and 1.5 comma 1. So these are the points that we're going to analyze. With that, we write our problem function. So maximum value of x plus 4y. So how do you get the maximum value of x plus 4y? So what we're going to be doing is we're going to be testing each of the points. So we're going to get this, the x value we put where x is, the y value we put where y is. We see what we're going to get. We do this for all the points, then we see which one is going to give us the greater, the maximum value, which one is going to be big. You can even, if you want, you can even pick more points, even a point on the middle. It will give you also an insight of what you can get on the middle depending on the question. So you can pick a point on the middle, you also try, but in this case I'll just test these 4 points. So with that being said, I'll start with 6.451. So if you put 6.51 where there's x, I've put 6.5, where there's y, I've put 1, you're going to get 10.5. So go to the next one, 6.5 and 3.5. If you do that, you're going to get 20.5. And we go to the next one, which is 4.4. When you do that, you're going to get 20. And we go to the last one, which is 1.5.1. When you do that, you're going to get 5.5. So what is the maximum value? So the maximum value, this is 10.5, this is 20.5. 20.5 is greater than 10.5. Then the next is 20. 20.5 is greater than 20. So this is still the maximum. 20.5 and 5.5. 20.5 is greater. So this is the maximum value. Therefore, the maximum value of x plus 4y is 20.5. And it is being produced by this coordinate 6.5 and 3.5. So sometimes they can ask you to identify the values of x and y that are going to give you the maximum value. So it's 6.5 and 3.5, and the maximum value is 20.5. So let's take a look at an exam question. So this is the English that I'm talking about. This is how it comes. But of course, sometimes they can plot a graph for you. They just want you to solve the problem function from the graph. But normally, it's supposed to be like this. So here's the question. A tailor at a certain market intends to make suits and dresses for sale. A. Let x represent the number of dresses and y number of suits. Write the inequalities which represent each of the conditions below. So now, this is the first part, converting word statement to inequalities. So, the first is the number of dresses should not exceed 50. How do you write this? The number of dresses should not be less than the number of suits. How do you write this? The cost of making a dress is 140 kwacha and that of a suit is 210 kwacha. The total cost should be at least 10,500. So this is question A. So you use x to represent number of dresses and y number of suits. Then you convert this into inequalities. That's the first part. The second part is about graphing. Using a scale of 2 cm to represent 10 units on both axes, draw x and y axis for 0x to 60 and 0y to 60. So your x value should range from 0 to 60 and 0, and your y values should range from 0 to 60. And 2 cm on your graph paper should represent 10 units. 2 cm is a single box on a normal graph paper. So each single box should represent 10 units. So you're going to start from in the x 0, 10, 20, 30, 40, 60, 40, 50, 60. Then in the y also 0, 10, 20, 30, 40, 50, 60. Just like that. So this is very important. So if you don't get the instructions here, you're going to have something fun. When you are done plotting your inequalities, you go to part C. The profit on a dress is 160 kwacha and on a suit is 270. What is the maximum number of suits and dresses the tailor must make to maximize the profit? So here we're going to do a very good analysis to come up with a problem function. Then the last part is what is the maximum profit? So these two questions are usually when you don't have, like, when you identify these numbers, you are going to, okay, let me just say that again. When you get the problem function, you're going to find the maximum value. The maximum value is what you're going to put here, and the two coordinates that are going to give you the maximum value is the answer for part C. So there is much that has been said here. You cannot fully understand. I do understand. So let's take a look at the solution step by step. So the first part is where we convert these statements into inequalities. The first one is the number of dresses should be less than 50. So number of dresses is being represented by x. So we're talking about number of dresses. Whenever you see number of dresses, you should see that should be x. So x should be less than 50. So we're talking about x less than 50. So x number of dresses and y number of suits. So x less than 50. We go to part 2. Number of dresses should not be less than the number of suits. Number of dresses should not be less than the number of suits. Meaning that the number of dresses should be greater than the number of suits. So number of dresses should be greater or equal to number of suits. That's what the number of dresses should not be less than the number of suits. That's what it means. It should be greater or equal to. Then finally, the cost of making a dress is 140 kwacha and that of a suit is 210 kwacha. The total cost should be at least 10,500. So I'm asking you to be with me here. The cost of making a dress is 140 kwacha. So making a single dress is 140 kwacha and that of a suit is 210 kwacha. The total cost should be at least 10,500. So let's analyze the part for the dress. So if the tailor makes one dress, then it's going to cost him or her 140 kwacha. If the tailor makes 2 dresses, then this number has to be multiplied by 2. If the tailor makes 3 dresses, this number has to be multiplied by 3. So to find the total cost, we just multiply the number of dresses with 140. Number of dresses, remember, is x. So number of dresses multiplied by 140 is x multiplied by 140, which is x times 140, and it's going to give you 140x. So that's how you get the cost for the dresses. And the same is for the suits. The suits are being represented by y. So number of suits multiplied by 210 is going to give you 210y because number of suits is y. So they are saying the total cost should be at least 10,500. So the total cost is 140x plus 210y because we have to add the cost of all the dresses that are going to be made and the cost of all the suits that are going to be made. The total, the total that we're going to get when we add is the total cost. But they're saying the total cost should be at least 10,500. So at least, meaning that the maximum value should be 10,500. Therefore, the total cost should be less or equal to 10,500. So we can write that 140x plus 210y should be, should be greater or equal to 10,500. That's what at least means. Sorry, I made the mistake. I was reading it as at most. So at least means greater or equal to. So 140x plus 210y greater or equal to 10,500. So you have dealt with this, you have dealt with this, you have dealt with this. You are done with part A. So you go to part B. So remember on graphs of inequalities, if you have been given inequalities, try to convert them into equations. So x less than 50 will become x is equal to 50. X greater or equal to y will become x is equal to y. Or if you want, you can make y subject, which is easy, because the equation of straight line has y as the subject, so you can make y a subject, or you can just write it as y is equal to x. And this other one, 140x plus 210y greater or equal to 10,500, is going to be a little bit problematic, but you have to make y subject. So the first thing is you put equals here. When you do that, you start solving for y. So 140x is going to be taken this side, and we're going to have 10,500 minus 140x. Then we're going to divide both sides by 210. When we do that, we're going to have this, and we end up with this. Y is equal to 10,500 minus 140x over 210. Don't worry, this paper 2, you have a calculator, so these numbers are just should be simple. Don't have to be scared about the magnitude of the numbers. So this is your third equations. So you're going to plot this on the graph. X is equal to 50, y is equal to x, and y is equal to this. And then we are going to shade the unwanted region. And of course, we have to remember that less than means dotted, then less than or equal to or greater than or equal to means solid. With that, let's continue. So they said using a scale of 2 cm to represent 10 units on both axes. I explained what this means. So I'm not going to use a normal graph paper, but just because of the technology that I'm currently using, but I will make sure that I give you an example that has a graph paper, a real graph paper. So this is the graph that I'm going to use use. So with that, let's try to plot. So we start with x is equal to 50. So x is equal to 50 is just a vertical line that cuts the x-axis at 50. You remember the secret I told you about vertical lines and horizontal lines. With that being said, less than implies implies it's a dotted line. If they are equal to, then it's going to be a solid line. So this is our line. So we have to shade the unwanted region. The region that we want is the less is this side. So for those who have developed the skill of being able to identify less and great, so less is this side. So we shade the unwanted, which is this. We go to the next one. Y is equal to x. So y is equal to x is we need to plot this one. This one you cannot just yes, you can. For those who are good with graphs, you can just plot even without coming up with some points, but we're going to use some tables. So we're going to have this table. We've got x here and we've got y here. So x, we choose just any points that we want that are on the graph. So I've picked 0, which is on the graph, and 40. So I want to see what are the corresponding values of y. So how I get that, how I get the corresponding values of y is, I'll use this equation. Where there's x, I'm going to be putting the values of x, then I get the corresponding values of y. So when x is 0, I put here, and I see that y is also 0, so I can put that. Again, when x is 40, I can put there, and y is going to be 40, so I can put there. So these are the 2 points, 0, 0 and 40, 40. So 0, 0, it's here. 40, 40, I go on the x 40, then I go up on the y 40. Therefore, my 2 points are going to be here and here. So this is 0, 0, and this is 40, 40. With that being said, I'm going to connect these 2 points with a line. But before I do that, I have to ask myself if it should be a dotted line or a solid line. And I tell that by the type of inequality here. So it's saying y is less or equal to. So the equal to shows that it's going to be a solid line. Then one thing I need to emphasize on is if you look at this, it was the original inequality was x is greater or equal to y. So I wanted to make y subject. So I took y on the left and x on the right. And this inequality symbol here, it has followed the change. If you look at it, the wider part, these legs where they open up, they are pointing x, and this smaller part here is pointing y. So it should be maintained when I change. So when I've changed, the smaller part is pointing y, and the side where the legs are widening is pointing x. So I just want to make that clear, because I've seen some students, they just take y here, take x here, and the symbol does not change. So the symbol should also change. With that being said, I'm going to connect with a solid line. So when I do that, I'm going to have this. The next is to identify which side is less and which side is great. So x, I'll use this one. Y is less than or equal to x. Y is less than or equal to x. So on these two sides, which side is less? So the less side is this. Okay, so there are ways in which you can prove if this is the less side. For those who remember, you can just pick a point on this side to find out if it is less. So if I pick, for example, this one is 0, 50. 50, 0, since x is 50, y is 0, 50, 0. So if you put 50 on the x and 0 on the y, you are going to see that yes, 0 is less than 50. Therefore, the appropriate side is this one, because here y is less or equal to x. Therefore, if 0 is less than 50, mean that it's balancing, which means any point here is accepting the fact that that y is less than x. So this is the wanted region. So we're going to shade the unwanted region. So in the shade we have that. We go to the last one. Y is greater or equal to this. So again, we create a table. First I just replace the inequality with the equal for calculation purposes. So I create a table. I choose 0 and 50, any random points, 0 and 50. Once I do that, I start putting where there's x, I put 0, where there's x, I'll put also 50. So starting with putting 0, with the calculator, I'm getting 50. And so mean that here it's going to be 50. So again, I go here, I put 50. So putting 50 here, with the calculator, I'm getting 16.7. So I'll put 16.7 there, which means the sets of points are 0, 50 and 50, 16.7. So we're going to, I'm going to graph 0, 50, 0, it's here, 50, it's here. And the other one is 50, 16.7, 50, 16.7. So 16.7 must be somewhere here between 10 and 20. So we have this and this. Now I'm going to connect this with a straight line. But before I do that, I have to ask myself, is it going to be dotted or it's going to be solid? So if I look at the original inequality, there is greater to, greater or equal to. So the equal to suggests that it's going to be a solid line. So I'm going to connect these 2 points with a solid line. Now, the last part is to identify which side, if we are supposed to shade, we have to identify the wanted region. So it's saying y is greater or equal to. So if we look at this side, is this side great, or which side is great, this or this? We're looking for the greater side. So for those who have developed an eye, this side is great, this side is less. For those who don't have an eye want to prove, you can pick any point here. You can pick this point, you can pick this point, you can pick any point that you're able to tell, but it should be on the same side, or it should be on this region. Once you do that, you put. So if you put and it gives you a smaller number this side, then this side is not the wanted side. So you can go this side again, you get 2 points, you put here. If it gives you this side to be greater than this side, as this inequality agrees with, then this side is the region. But if you do that, you're going to get this side to be the region, and therefore R is on this region. For those who have an eye, we can see that the upper or right side are usually greater, so this side is greater, so we shade the part that is not great. With that being said, the region we want is this, so this is our R. So the next question is, which is question C. The profit on a dress is 160 and on a suit is 270. What is the maximum number of suits and dresses the tailor must make to maximize profit? The profit on a dress is 160 and on a suit is 270. What is the maximum number of suits and dresses the tailor must make to maximize profit? So we need to come up with an equation that gives us the maximum profit, which is going to be the problem function that we're going to be solving. So the profit on a dress is 160 and on a suit is 270. So mean that if the tailor makes sells one dress, he or she is going to make 160. If he sells 2 dresses, he or she is going to make 2 times 160. So then the number of dresses should be multiplied by the profit on each dress. So the total profit he or she can make on dresses is x times 160, which is 160x, and on the suit is y times 270, which is 270y. Then the next question is, what is the maximum profit? So these ones, we usually find them together. So here's the solution. Total profit, like I said, 160x plus 270y. So we want to see which sets of points are going to give us the maximum value. So we're going to pick the corner points, the crucial points, or the points that I had shown you that are usually used, which are the points on the corners. So we're talking about this point here, this point here, this point here. But be careful, don't choose a point that is on a dotted line like this one. So if you choose this point here, since there's a dotted, you're going to shift it a bit, you choose this one, just like that. So with that being said, we have this point here, and this point there, but this point here is on the dotted line. So well, this one we're going to shift it a bit, and this one we're going to shift it a bit because they are on the dotted line. So I've got these 3 points, 1, 2, 3. So let's pick their coordinates and we put in, we see what's going to give us. So these are the coordinates. We have 46,16, 30,26, 48,48. Yeah, so the coordinates, how to pick them, for example, I'll just demonstrate for this one. So what's the coordinates for this one? If we go here, it seems like it's 30, and if we go here, it's 26. Don't worry, this is just it's not a standard graph. You'll learn more on how to work with the standard graph. So this is these are the points. This is how to pick the points. You pick the x value and then you go to the y value. So once you have these 3 points, you start testing. So we're going to be putting the x value here and the y value here. We see what's going to give us. So we start with 46,16. So maximum profit, where there's x we put 46, where there's y we put 16. So when we do that, we're going to have 11,680 as the maximum profit. Let's try another point, which is 30,26. If we do that, we're going to get 11,820 as the maximum profit. Let's try the last point, which is 48,48. So maximum profit is 160. It's 15,360. So which one is great among these? Because they're looking for the maximum profit. The question can be different. Sometimes they can ask you for the minimum profit, which you have to choose the smallest number of these. But here is the maximum profit. So the maximum profit here is going to be 15,360 because it is the largest of these 3. And the first part of the question is saying, what is the maximum number of suits and dresses the tailor must make to maximize profit? Then the last question is what is the maximum profit? So for that question, this is the answer. Then for question C, the points that have given you the maximum point are the answers. So 48, 48. 48 is X and 48 is this other 48 is Y. So 48 dresses must be made and 48 suits must be made to get the maximum profit. Therefore, the maximum number of dresses 48 and suits should be 48, and the maximum profit is 15,360 kwacha. So this is how to deal with linear programming. Wow, 30 minutes. A lot of information, but of course, you just have to take your time, analyze each part, and you're going to get it. For now, happy solving.